But one of the things that we're really considering is the find rate. Are we getting better at finding bugs? Are our tools becoming less effective because we've found the bugs that this particular tool knows how to find? This is why it's important for us to look at the find rate. And it's also important for us to know, how many have we found and what is the overall severity there. So that helps us identify what methods are productive and what methods are, let's say, less productive. So it helps us figure out where to put our time. So for example, we did some work in source code analysis. Actually, one of the source code analysis vendors came to us and asked, and did some work on our code base, ran their tools over it, and then reported that they had identified 300 vulnerabilities in the Firefox code base. And what they had actually done is flagged 300 constructs that could potentially result in vulnerabilities. But when we looked through these, none of them actually resulted in actual vulnerabilities. So this particular tool was 0 for 300. So we can look at that and say it's not a very effective tool for us, and that it's, as a method, our investment in time is probably better spent elsewhere.
And one of the things that people need to sort of track is what's the cost to your organization of waking up one morning and you read the headline or you get an email from your VP that says this tool found 300 vulnerabilities. What are you going to do about it? If there are 300 vulnerabilities in the product, you've got to do something about it, and you got to do it very quickly. And the energy cost for dealing with those false positives is higher, I think, for security bugs than for pretty much any other kind of defect. I'm going to talk a little bit later about some areas where we have had good success with source code analysis. But again, as is a pattern through a lot of this talk, it's more about making sure that the things you do suit your environment and your product and are aware of the things that can take advantage of your experience than necessarily taking the tool that worked great for somebody else and applying it blindly. So certainly you need to be, if not cynical, you need to be careful in how you interpret the results of tools and reports from other sources that may not know your product as well as you do.
So one of the things that we look at is okay. So are there themes? Anything that we can pick out here? Is there a trend? These spikes are the points where Jesse introduces new tools here. So we're like, okay, new tool introduced, it becomes less effective over time. New tool introduced, less effective over time. But we're able to identify, okay, these tools are effective. Jesse's good at writing tools. I think this is what we're able to determine from looking at these things. But we're also able to evaluate, okay, this tool is no longer effective. Maybe this is a point in time where we can make it available to the public and see if other people can maybe tweak it and make it more effective for us. Or maybe they can use it in different projects and make it more effective. And we were able to use that to identify that we were able to make the tools that we're talking about today available.
We'll take actually questions at the end if you want to.
He's asking what are the numbers here. So like the point of the slide is actually to demonstrate that we're seeing, when we see spikes, like we can attach it to something else. But we can make the numbers available. I don't have them here in front of me, obviously, because this is, we're looking at the same thing. So things that we're looking for are, actually, if you want to.
Yeah, this is again an area where the philosophy of why we use tools, I think, is valuable to share. Window will ask what methods are most productive, and Jesse will have found a new way to blow up some piece of our browser. What happens when I poke it in this way? And then, of course, all the various engineers are like, why do we even let people poke it in that way? And it's because it's the web, of course, so you have to let them poke it in various ways. But for us, one of the real values of tools is that they let people who are experts empower people who aren't experts to find bugs in these ways. They let you capture that expertise in some piece of software that can be used even by a mortal software developer. And use those tools and techniques, whether it's to extend the domain language that the fuzzer might search, or to run it over different kinds of patches that they're working on to make sure that they haven't regressed in an important area. That aspect of tools is I think, at least as important to us as the automation aspect of it, though, as we'll see, the automation aspect is pretty powerful as well.
The other thing we're looking at is fix rate, and this is actually important to identify, because if your fix rate is lower than your find rate, then you will end up with a backlog, and that's a scary place to be. That means you know about a whole bunch of bugs that you can't get fixed quick enough, and you're constantly adding to the set of bugs that you know about. And so over time, the tail is growing, and you can't keep up with it. So that's a scary place to be. But if you don't know your fix rate, then it's hard to identify if you're in that situation, if you're slowly digging yourself out of that hole, or if the hole is getting deeper. So it's important to track things like your fix rate. It also helps us identify, are we looking at some bugs that are incredibly difficult to fix, and are they backing up the rest of the rest of the queue? How can we schedule our resources a little bit more effectively?
And also, where do we need an architectural change that may not be suitable for an update, where we need to mitigate in one release, but we need to take a different approach in another major update to change architecturally how we deal with this class of attack or this class of operation. And looking at the information about fix rate, whether you're heat mapping your code or you're looking for patterns in, whose code most frequently has this bug, those are things that help you identify where to spend your resources and where you may need to change tactics in order to get to the fix rate you want.
For some bugs, you actually have to play whack-a-mole, and as they come up, whack them back down. But if you can implement a architectural level change that mitigates a whole category of bugs, and then you can knock out maybe 10 or 20 at once, and that's important to realize. And recognizing when those things are being successful is one of the reasons that you want to track the fix rate. And it also helps us identify regressions as well, because it's hard to identify how expensive a particular cost fixing a bug is going to be in terms of how long it's going to take until you actually get into the guts of it. But if you have a rate of regression over time, you can use that as part of the cost of the fix, because that's at least something you can average from previous fixes. So our fix rate ends up looking like this, and it's hard to tell for us what's going on. So we're still looking for trends in our own fix rate and trying to tie it to something else. But what we're seeing is that we are the places where it spikes are places where a major fix lands that mitigates a broad category of vulnerability. So we can make sense out of it at that point. But in terms of are we getting better at fixing things? Are we fixing more and more bugs at the same time? Well, we are able to fix more and more bugs when we add more people to the set of people who are fixing bugs. And we are able to fix more bugs at a time when we implement architecture changes. But we absolutely need to add more people to our to the set of people who are fixing bugs, because our find rate is getting pretty high up there too. And we're, of course, constantly encouraging you guys to hack away at the product and identify vulnerabilities and report those as well. So as you guys take up that challenge, then our fix rate needs to get better too. So if there's other people here who want to help out on the fix side, not just the find side, we'd love to have you participate. This is another case, too, where picking your metrics and picking how you align your organization around them can have a really profound effect in the downstream security of your system. If the edict is our fix rate needs to exceed our find rate, you're incenting the system to underreport bugs, right? You're saying, well, we should have somebody going and fixing some of these things instead of, fixing one bug instead of writing something that might help us discover 50 of them. And that may not be the right behavior to get you to where you're looking to be in terms of security of your product. If we wanted to just optimize, if our goal was the next year at BlackHat, we're going to be able to show these two lines and one's bigger than the other and there will be rousing applause, we would just put Jesse in a box for a year. And that would be fine, and we wouldn't find any of these bugs. Other people, of course, are not motivated to keep our fix rate above our find rate. They're motivated to find as much as they can. So we need to stay ahead of that, and we need to figure out how to be smart about how we approach fixes as well. But that one top line number can be misleading, and it can point your organization in the wrong direction if you're not careful. You can also use these numbers to identify a need for headcount for the set of people who are either fixing or testing. So the last set of metrics that we're looking at is really two parts. It's the overall window of risk, the opportunity an attacker has to potentially exploit a vulnerability in the software. And that's made up of two parts. And the first of these is how long does it take for the vendor to ship a fix once it's identified. And the second part is how long does it take for these to get the patch installed. And that's important, and I think part of the story that's been largely ignored until recently, because attackers don't care whether or not the fix is available or whether the user doesn't have it installed. If the user is vulnerable, then that's all they really care about. So I think both parts of those are really pretty important. So on time to fix, we're getting better over time, and this is actually largely due to your support, and we want to thank you for that. We have about 20,000 people who download nightly builds every night, and that's incredible, because that means that we're able to test our fixes against 20,000 different host configurations with 20,000 different driver sets and 20,000 different applications with 20,000 different users doing different things on 20,000 sets of websites running 20,000 different configurations of plugins and add-ons, and that's huge, because we couldn't get that kind of breadth no matter how many resources we had internally to throw against it, right? That's an amazing test bed, and so your support in running nightly builds is what enables us to ship fixes so quickly. That is you can get a little bit better at identifying the problem once somebody reports it and poking around nearby and seeing if there's similar issues. You can get somewhat better at that. You can get a little better at identifying how to fix it. You can get a little bit better at building the fix a little bit quicker. But the thing that we are making the most progress on is reducing the time to test, and that's what we're able to do through the support of the community, and that's tremendous. And that's people, that's users, that's developers, that's our neighbors, that can be really anyone. Run the patch, run the build. If you have any problems, let us know about it. Otherwise, we develop confidence in the integrity of the patch, and we're able to get it out quicker. The other half of this is time to deploy. How long does it take for the user to get the update installed once it's available? And this is one that we've been tracking, but have only recently started to use it to evaluate whether or not we're doing a good job internally and talking about it externally. For us, this has been tremendous since the implementation of auto update, because it means that users are able to get fixes automatically. They don't have to go out there and dig for the update themselves. Once they hear about it, it's actually sent to them directly, and that's tremendous. And it also helps us identify what percentage of our user base is updated through the requests that come in to identify for auto update. So this is what the upgrade cycle looked like this is last year, when we shipped 1.5.06. So this is the cycle from 1.5.05 to 1.5.06. The red line is 1.5.06, and the blue line is 1.5.05. And it's not a pretty chart because I'm not that good with Excel. But on day 3, you can see that there are more people. So day 1 is when the patch shipped. Day 3 is the day that more people have the patch than don't have the patch. And by day 8, you can see that about 90% of our user base is updated. And I thought at this time, like 8 days ago, that 90% of the user base being updated in 8 days is pretty tremendous, because we're talking about 100 million users or something like that. That to get everybody updated in about 8 days is pretty amazing. So this is the upgrade cycle for 2004, and this was just in June, at the very beginning of June, when we shipped 2004. I'd actually like to see these numbers for 05 and 06, because those shipped out back to back at each other. But what we're seeing here, and even though these charts look exactly the same, as Mike was pointing out to me, the difference is that this chart's only 6 days. It takes 6 days for 90% of our user base to get updated, and that's tremendous for us. And that's due to some changes in our infrastructure and some support from our mirrors, and that's pretty tremendous. That means we're able to get that many more people serviced that much quicker. That's a 25% improvement and a reduction in the amount of time that users are vulnerable.
And that's certainly, as an engineer, that's a very gratifying experience, right? You worked hard to fix this thing. You did it because you think it's important to protect users. You know it's important to protect users deep in the core of you, and you want to see those users protected as quickly as you can. So being able to see that stuff in the hands of users as soon as possible has a big effect. The question is, how do we know this represents all of our users? And we don't. It's a stochastic analysis of it. One of the perils, one of the costs of being very attuned to our users' privacy is that we don't track individual users in that way. People can get their sources. There are people on intranets who talk to different update services that have been set up in different places. But with the scale of 100 million users and looking at the scale of the pings that come in, we're quite confident that these are representative numbers. We have a economist statistician actually on staff now who will be climbing through